Well, hi and welcome to the first in what will hopefully be a very short series, maybe only one video if I'm really lucky, on fixing my tube tester. You know what, I have to make this my next project because I just kind of feel so bad about what happened to this poor guy in my last series. In case you didn't watch it, what happened to my tube tester is I plugged a tube in here and it started glowing like a light bulb. And that's because I had the settings set for a slightly different tube number. And I basically applied plate voltage to the heater on the tube. I'm pretty sure that's what I did. And after that, my tube tester is not working well. So that's why it's going to be a topic here of this video as I sort out what's gone wrong with it. Now, it's a very, very simple manual here, but it has in it a circuit diagram. Now, I've been studying it a little bit here, trying to get familiar with it. Of course, this is laid out, you know, like a circuit diagram. When we look inside the actual tube tester, it's not going to look like this exactly. But one thing I did notice is that there's quite a few diodes in here. These are silicon diodes. There's 1, 2, 3, 4, 5. You know, probably a couple more if I keep looking. 6. There's another one there. So, you know, it wouldn't be too far-fetched that one of those is blown. You know, most everything else is pretty rugged in this thing. It's just a pile of switches. And there is one vacuum tube. And I'm not sure if what I did could even affect the tube that's inside the tube tester. So I'm really suspicious of the diode, so I think that's what we'll probably be focusing on. Now, I'm not going to turn it on and demonstrate that it doesn't work. That was made pretty clear in some previous videos, so I'll just get down to opening it up. I don't think I've ever had this apart before either. So it should be pretty straightforward. It's a quiet day in Jim's shop. Yeah, I just don't want to flip this over and find, you know, a burned out cinder. That would be pretty surprising. I think what we're going to see is something that's in really good shape. One more. A bit of reflections from my lights here. Okay, here we go. Okay. Look, it's an empty box. Here we go. Very musical. Okay, here's what we got. Yikes! There's a lot of stuff in there. Okay, so let's do a little visual inspection here and see what we can spot. Now I'm just looking for my magnifier. Where'd it go? There it is. Okay. Just 1 second. Hold the horses here. There we are. Okay, I figured out a way to hold this magnifying lens and the camera at the same time in one hand. So, what do we got here? We got a bank of components running right along through here. Capacitors of various sizes, high wattage resistors. It's all looking pretty good. Okay, there's the tube. Well, that's not a tube. Wait a minute. Hold on a second here. There we go. That's it. Look at that tube. Can you see inside it? We'll take a closer look with the other magnifier in a moment. That's the tube that I saw on the schematic. This is something a little different. That guy could get damaged real easy. Oh, I hope it's not that. Okay. Oh man, my fingers are crossed now. There's the banks of rotating switches down there. And the rotating switch. Oh yeah, I'm the guy who likes switches. No, I'm not the guy who likes all these switches. These would be a little different than those wafer switches, though, in radios. Hey, where are they hiding half the parts here? Is it down under here? Where's all those diodes? Well, this might be some of them right here. Maybe there's silicon diodes, or germanium diodes, or copper oxide diodes, or something else. Actually, look, I can see the diode there. There's one right there. Another one over here. We'll have to check those. There's a number of adjustments here. chance to do a calibration on it. Some kind of a little capacitor network there. And there's the big honking transformer with so many outputs. Yeah. Okay, I think we'll have to give these guys a test here. Okay, so what we're going to be doing here is testing the different diodes. I've already had a quick peek at them with the meter here. So I'll just run you through it here a little bit. So there's a diode right over here. Right over here. It's got GE written on it, and I think that means germanium. Ohm meter set to 200K here. We get to 2.8K. The other way, well, we have to look and see where this is in the circuit to really know for sure about that. Now, there's a couple more diodes right here. Move this forward here a little bit. Right here. Hard to see, but this black structure thing here has two diodes. Some kind of a bizarre heatsink arrangement they've got here. And then there's these, which look like selenium rectifiers. We got everything coming at us here. So let's check this one here. It's 4K that way. $6K that way. I put my meter down on diode. Nothing one way. A little lower reading than what you would expect, 319 millivolts. But I think that indicates those are fine. These are pretty rugged. Germanium one, I'm not sure how rugged it is. Now the selenium one. It's actually two of them connected. And really, each of the plates is kind of a thing in itself too. But so we're still on the tester. Here we go. Nothing there. Reverse. Nothing there. The other one, the other side. Briefly, something there. It looked like a capacitor charge up to me. Let's see if it shows up the other way. Yeah, I don't know how that could be actually. How could that be? So we got nothing there. Let's put it on. That's 2 megohms full scale now. So we're reading about 800K that way. I mean, these things are in their circuits, so can't put too much weight on these tests just yet. Pretty similar, right? 980. don't think it's going to get to 980, but it's going to be close. They're pretty similar. And if I try it here, I don't know what to make of these measurements. Wow. $719K that way. I don't know if I'm proving anything with this. Let's take a look at the circuit diagram here. Remember, there were a lot of diodes now. There's two right there. There's one there. One there. Two here. Well, let's see. There's a black wire. Leaves here. Goes into this bundle. Out of that bundle comes a black wire here. Is that a black wire there? It's like a black wire there. This. Okay, let's see which one it is. That's one end of the black wire, and here's another end. Yep, that's it there. So it goes to a 2000 ohm resistor. I have to use this chart. Okay, where is a 2000 ohm resistor here? $2K right there. R11. 2K. R11. It's going to be near one of these diodes. There it is there. It's not near any of the diodes. Come on. Okay, back the card up here. Coming off the top of this. Showing up here where there is a 2000 ohm resistor. That's the only 2K resistor in there. R11. R. Well, it could just be the way they've drawn it here, and in fact, no, it goes right, supposedly right to the 45 volt tap on the big whopping transformer. Oh yeah. No problem tracing that. Okay. I don't know what happened. How about we trace the other one? Let's trace the, let's see. Yeah, this one I can practically see the whole run. It was right here. There's no question about this. Yeah. And that's to this capacitor here. 20 millifarad capacitor. Right off the diode. Okay, so I can right off the double diode straight to a capacitor. There it is. C3, C3, C3. Oh, there's more parts. Another 2K resistor. Okay. This is gonna work out. 20 millifarad. No, what did I say it was? No, I got too excited there. Off the double, C3, 10 millifarad, 20 millifarad, 20. Here's another capacitor. No. It goes to R7. R7 is a 2K. So, yes, right here. 10. There it is. Presto. There it is. Okay, so now we know for sure, without a doubt, that this is this. Now, what is it doing there? Wow, that's an interesting thing here. You see this line comes down, it's across, goes up through the winding into the grid of this 3A4 tube. Okay, that's not what I thought it was. Grid to the grid. Well, I got to think about this for a little bit.